Hello again, everyone. Time for video number 3, I believe. So this time we're going to be looking at forces. So with forces, our essential question is going to be, how do forces affect the motion of an object? And I wish it were May 4th, because then I could be like, May the 4th and the force be with you, but it's not. So I still did it, but it would be even better then. It starts off with a quick video, so we're going to watch this guy stack some bottles and wonder, how does he do it? I don't know, but we're going to see. So it is pretty impressive, but odd that this is his talent as well.
Merritt Smith, you're checking out. Merritt Smith, you're checking out.
How does he do it, folks? We'll never know. He's like the Mr. Miyagi of bottle stacking, alright? The Jackie Chan of glass bottles. So, also shout out to Sunrise Science for these awesome PowerPoints. They hook us up with our notes that we have, as well as the PowerPoints. If you would like this information, Teachers Pay Teachers. So you can find all of that there. Vocabulary that will be important for this section on forces is magnitude. Alright, magnitude is an amount, or how much strength is being applied to something. So, target question number 1. What is force? What is force? A force is any influence, such as a push or a pull. That is the definition that I like to use on force, a push or a pull used to move an object some distance. So a force is any influence such as a push or pull that causes an object to move or change its speed, direction, or shape.
Riley Tucker, you're checking out. Riley Tucker.
We're going to be hearing a lot of those, so I'm going to go ahead and apologize in advance because a lot of people are checking out. So I'm trying to film this at the end of the school day, so we're going to hear a lot of that. So what you need to know, force, push, or pull on an object that causes it to move some distance or change its speed or shape. What is a force? A force has a strength that is measured in newtons, named for Isaac Newton. Next section we're going to be looking at Newton's 3 laws. So when we're measuring how large a force is, the units that you guys are going to be using for force is the Newton. You're just going to abbreviate that with a capital N. A force has a direction, so it's also a vector. So right now we know a couple of things that are vectors. We know acceleration, force, and yeah, thanks Macy. Velocity. Those 3 are all vectors. Speed is not. Speed only has size, not direction. So if you were going to abbreviate it, you can abbreviate it with a capital F with an arrow over it, just showing the push or pull on that object. What are balanced and unbalanced forces? So when it comes to forces, there are 2 types. You have balanced forces and you have unbalanced forces. A balanced force is equal in size yet opposite in direction. So the net force is 0. If you were going to add up both of those forces, they would equal 0. So if one force had 5 newtons, the other one would have negative 5 newtons, because together that would equal out 0. It's like tug of war. Hey bud, can you hold that rope? Thanks. So, I got my friend over there, and we're going to play tug of war, okay? If we are balanced forces. All right? No matter how hard I pull in this direction, they are going to pull with the same force in that direction so that our flag in the center would stay centered, right? Neither one of us are winning this tug-of-war challenge. The forces being applied are balanced forces.
Coach Campbell, if you're on campus, please call the office. Coach Campbell, if you're on campus, call the office.
They do not cause a change in motion. So again, that flag would not be moving during our tug-of-war. Gravity pulls down with the same force that the floor pushes up on. So Tweedledee and Tweedledum don't move. So standing here on the floor, it's not like gravity's just pushing us, pushing us, pushing us. The ground is pushing up with the same force, so we're just chilling, so to say. Unbalanced forces. An unbalanced force unbalanced forces are not equal in size and or are not opposite in direction. So they could be going in the same direction, they could be going in opposite directions, but with different amounts of force being applied. So whatever it is, the net force will not equal 0. So here we see cat dog, cat dog, cat dog, right? Alone in the world with a little cat dog, right? So it's a dog. So we see a dog with a shoe, okay? The dog is going to be pulling in this direction. The shoe has a force because it has a weight in this direction. However, the dog has much more force being applied than the shoe, so the shoe will move in the direction of the dog. An unbalanced force does cause change. So when forces are applied and there is a change in motion, we know so because there is an unbalanced force of being applied. So me, going back with this tug-of-war match, right? We all know how strong I am, right? Guns. Firepower, right? No one's seen that movie. Not at the museum. So, if I have one end of the rope and my opponent has the other end, right? And we're in this tug-of-war battle, and I'm much stronger, so my force is going to be much more, and I pull. Well, you get the picture. It's going to cause an object to move. Now we see that that object is a chair, so as long as the force that I apply is greater than the force that the chair applies by having gravity on it, then that chair is going to move some direction. So we say again that is an unbalanced force. So again, dog pulling it, since the dog is stronger than the force of friction or the weight of that shoe, it's going to end up pulling the shoe backwards. Alright, what is net force? Net force on an object, good definition to know, is the combination of all the forces acting on that object. This determines if and how an object will accelerate. So here, we have some forces being applied. We have a frictional force of the wheels on the ground, applying a force of 15 newtons to the left. We have an applied force by this little girl pedaling of 20 newtons to the right. Alright, so 15 to the left and 20 to the right. When you add those together, we're going to pretend that the 15 to the left is a negative 15 because it's going to the left, remember our number scale, and the 20 to the right is a positive 20. So negative 15 plus positive 20 will give us a net force of 5 newtons to the right. So if the forces working in opposite directions are not equal, the net force has a magnitude equal to the difference in newtons between those two forces, like we saw here, with it being 5 newtons. And a direction that is the same as the stronger force. Stronger force in this case is 20 newtons, so it will be to the right as well. Alright, what are some types of contact forces? With a contact force, the surfaces of two objects are going to be in contact with each other. Somehow they are touching each other. 4 types. First one are 4 types of friction. We have rolling friction. So a tiny bit of the surface is in contact, like the road and the wheels on your car, right? Your whole wheel is not in contact at one time, only the part that's touching.
Jaden Martin, wherever you're at, you're checking out.
Static friction. This is what allows you to be able to stand, allows you to be able to walk. If you've ever watched Magic School Bus, there's an episode where they play frictionless baseball and they see how hard it is. Because once you started in motion, you would just keep in motion because there would be no friction to hold you. It would be like permanently ice skating. your whole life away. All right, you would just be constantly moving. You could slide a book across the table and it would just keep sliding. All right. Sliding friction, continuous surface contact like this slug. Fluid friction, the motion of liquids or gas particles against the surface, or what we know as air resistance. And again, friction is caused by contact of surfaces. It slows down or opposes motion and turns motion into heat. You guys know that. If you've ever been really cold at a game or something, you rub your hands really, really fast together, that's friction. It creates that heat in your hands so that your hands warm up, right? And you continue to create that thermal energy by rubbing your hands together. Alright, what are some types of contact forces? So here again, touching. We have buoyancy forces. Alright, it's the upward force of fluid against an object. It causes an object to be able to float. So here we have the buoyant force pushing up against the bottom of the door wall. Again, may be real, may not be real. Alright, and we have gravity pushing down as well. So the buoyant force is overcoming the force of gravity to allow that object to come to the surface of the water. Tension, a strain or force due to pulling. Ropes, bridges, pulleys, and that type of thing work on tension. You've heard of tension bridges and that type of thing. And so it is a force pulling on a rope or a pulley system, that type of thing. Now, non-contact forces. We have gravitational non-contact forces, which is an attraction force exerted between all matter in the universe. Magnitude is affected by two things. So, used to do on February 14th instead of Valentine's Day, we called it Gravity Day, because gravity is the force of attraction. So you want to pick up one that you can use that hasn't been like, oh, is your tag say made in heaven? No. Alright? It's, hey girl, I feel like there's some gravity between us. Because it's the force of attraction. Again, science puns never get old, right? If you want an element pun, you could be like, hey, feel the charge because I got my eye on you. Eye on? No? Yes? Maybe. Maybe you remember, maybe you don't. So here we go. Back to it. So gravitational. We have mass and distance. The larger the planet, the more gravity it has. So our smaller planets, our smaller moons, smaller objects in the solar system are going to have less gravity. The larger objects are going to have more gravity, a stronger pull, like the sun. Distance. The closer they are, the more gravity that they have for each other. The further apart, the less gravity. That's what holds planets in orbit, is that gravitational pull. So the larger the planet and the closer it is, then the more gravitational pull that it has. So that's why you would weigh more on Earth than you would Pluto, and so forth. What are some types of non-contact forces? Again, we have electrical. That's interaction between positively and negatively charged matter. Right? We've seen those ions. Again, got my eye on you. You didn't know that would happen. But electricity is just the flow of electrons or the flow of charged particles. So here, this is the interaction between that positive charge and the negative charge in order for electricity to flow. And then magnetic, the north and south poles of a magnetic material create the magnetic force field, right? You don't have to touch to know that there's attraction between those. When you have a magnet, you can literally repel them or cause them to be attracted to each other before they ever even come in contact. So we've seen that before. And then we have some sum it up questions. So you're going to practice what we've gone over, answering the following questions. Again, you can use your notes on this as well as the test now. The test will be in Google Classroom. These tests are to assess what you've learned. They will not be copied over to the grade book. So just keep that in mind. Alright, hope you guys are well. Hope you're staying safe. Hope you're staying healthy. And I hope I see you soon.